Nice to see everyone. Well, I'm going to follow that lovely talk about tangible physical network lines with measurable latency with a talk about opinions about software abstractions. Sorry, but you have been warned. So, recently, in the world of crypto 2025 that we find ourselves in, whatever exactly it is, people are asking themselves a little bit more than they used to when the prices were higher, what Ethereum is for. Maybe it should be a world computer, maybe ETH should be money. DBA published a great blog post a few months ago from my perspective, it was a great blog post, and I don't know if it achieved, causing the kind of reflection that it was seeking, but hey, steps in the right direction. Talking about North Star, that term was very popular a few months ago, and talking about world computers. And I myself, like I think most people, I took world computer to be a kind of marketing slogan, and I never really thought very hard about it until recently. So I'm going to tell you what I've been thinking about. Hopefully you'll find it interesting. I'm going to start by just talking about going through a little bit of the history of the term, thanks to Patrick in the audience somewhere for helping me do some research. And then talk about what it would mean to take the metaphor seriously and what that would kind of imply on the design of Ethereum, that Ethereum doesn't, requirements that it doesn't satisfy today. Then I'll talk about how maybe Ethereum could actually become a world computer if we take this more seriously. What is a path to get from the Ethereum where we are, the Ethereum that exists today, to the real world computer. I'll propose maybe a somewhat opinionated path that might or might not have something to do with Anoma, but then that's not the only path, and I'll also talk about another one you could consider. And I'll end with some takeaways. So I think it's always interesting to take a look into history, easy to forget that in the world of the now. Where did the term world computer come from? I did a little bit of bisection. If you go back and read the Ethereum white paper, nope, world computer, never there. Control F world computer, nothing. Nothing even like it. Ethereum yellow paper, also nope, it has a lot of, Gavin Wood is really a fan of this arcane Greek notation for state transition systems. Never got white, but it's cool, but doesn't use the phrase world computer. Ethereum launch video, if you go back, I have a screenshot of this actually, which I'll just show you. If you go, who's watched this video? Raise your hand. You should do it. It's a minute and a half, and it's interesting because it proposed something pretty different than the Ethereum that exists today, and sort of the goalposts have shifted, and I think maybe we haven't noticed. So the Ethereum launch video, not only does it include the phrase world computer, the Ethereum launch video is literally called Ethereum: the world computer. I mean, you want a clear North Star, there it is, 2015. What are you waiting for? So somewhere in between these things, the term came into use. Where? Thanks to Patrick and Google Gemini and whatever data they stole from whoever over the course of human history, I have at least managed to pinpoint where Vitalik first used it, which is at 5 minutes and 22 seconds on Future Thinkers Podcast, episode 016, Ethereum and How to Build a Decentralized Future. This is also a fascinating podcast. All these, I feel, I don't know if anyone's a Nietzsche fan or not a Nietzsche fan, but if you read about eternal recurrence of the same, this is like crypto Twitter in a nutshell. It's all 2015 on repeat, at least in this case. There are a few great quotes from this podcast, and I wanted to offer a few choice ones, which I will just read. One, Vitalik is talking about kind of the history of Ethereum, and he says, originally Ethereum was just meant to be a decentralized platform for financial contracts, but one of our communications people, Vinay Gupta, describes it as being, quote, the world computer. The idea is there exists this magic computer in the cloud, and anyone can send programs to it, run programs on it, those programs can talk to each other, and you can trust that this computer will run the programs in the way that you specified them to run. I mean, sounds great. Take a look at this launch video, also describes the concept, a few quotes. How will the internet work in the future? Not how will financial contracts work in the future, but how will the internet work in the future? It will use Ethereum. Ethereum is a planetary scale computer powered by blockchain technology. Not Ethereum is a blockchain. Ethereum is a planetary scale computer powered by blockchain technology. Ethereum is the secure backbone for everything from e-commerce, well, there's kind of some of that, to Internet of Things. No, definitely not. Ethereum handles user authentication and secure payments for you, as well as messaging and even decentralized storage. Interesting. Another diagram from the past that plays into this question of what is a world computer and what are we trying to do here anyways is this fantastic one, which is a diagram of Ethereum. You'll see there's a blockchain in the center, but then there's also some other things. There's some kind of local store, there's a protocol called Swarm, another protocol called Whisper for decentralized storage and messaging. And these were, originally part of the vision of Ethereum. They're mentioned in the launch video, they were in all of the material around the ICO and stuff like this. And then they kind of just slowly vanished. They didn't go out with a bang. There wasn't an announcement, we've canceled decentralized storage. We've canceled the world computer. They just slowly vanished. So I think we can kind of just mine these data sources to ask the question, what did people want a world computer to do? Because they were already thinking about it in 2015. People want a magic computer in the cloud that can handle everything from e-commerce to the Internet of Things. I mean, sounds good to me. The key aspect here, you notice what that video doesn't talk about. It doesn't talk about many things. Not even necessarily rollups or L2s or these are quibbles. It talks about one thing. It talks about one world computer that you can use and interact with as if it were a single thing in the cloud. So the typical sleight of hand nowadays is to say world computer and mean the Ethereum blockchain, right? Oh, let's make Ethereum the world computer, let's make the blockchain faster, let's scale it, let's increase the gas limit, let's accept slightly higher validator hardware requirements, etc. But a blockchain just isn't this thing. It's not a magic computer in the cloud. It's a very specific thing. It's a replicated state machine. And Ethereum understood this in 2015. They didn't pitch the blockchain as the world computer. They pitched this whole system, which included lots of other components. Saying that a blockchain is a world computer is a bit like saying that a single CPU core is a PC. Your PC needs the CPU cores to work, for sure, but there are also other pieces of hardware that do other things. And it only works, if you just have a CPU core, you have, you have like a few megabytes of storage, right, in your computer. Doesn't really work. You have no networking. Doesn't really work, etc. So even Ethereum understood this in 2015, but I think we've kind of forgotten it. What happens if we take this metaphor seriously? So we want a thing that behaves like a magic cloud computer, and I'll try to make that a little bit less magical in the next few slides. Users should be able to send messages to and from it. They should be able to get responses, maybe even have data automatically synchronized. We want this computer to be able to run arbitrary programs, not just programs that need totally ordered, high-integrity data, but arbitrary programs. And we want users to be able to trust that those programs will run correctly in some way, which might be different for different applications. And in particular, as Ethereum pitched in 2015, we want to be able to run on this world computer everything from e-commerce to the Internet of Things, which means that it needs to deal with this kind of heterogeneity of state models, of trust requirements, etc. So I'm a big fan of simple diagrams. And if we're to make a diagram of the thing which Ethereum pitched in 2015 as this magic cloud, magic world computer, I think it would just look like this. There are users, and they send messages to the world computer. How that's implemented may be a separate question, but this is the abstraction. And they get responses back. Alice, Bob, Vitalik, Satoshi, they're interacting with the world computer, and it looks like one circle. Now, part of what makes the sleight of hand is, I think, a confusion of what this means. Because this looks like one circle, and you can take one circle and say, oh, we have a blockchain, and we have a bunch of validators, but they're agreeing on blocks, so we can abstract it as one circle, and this thing is the world computer. But this is not, trying to instantiate that abstraction with just a blockchain doesn't work. There's not physically one thing, right? Unless you pick a single location or, sure, a single set of validators to produce blocks, but then you have only one security model, then you can't do all the other things that we were promised a world computer would do. So the thing that we really have is not this. The thing that we really have is a big distributed system with a bunch of different nodes. There's somewhere in San Francisco, there's WorldCoin SAR on HQ, there's that Hetzner server you forgot about, there's Vitalik's laptop, there's, I think, bitcointalk.org servers used to be operated by someone named Sirius, but they kept getting DOSed. You have a messy system. And what we want to do is take this messy system and make it act as if it were one thing. Act as if it were a single world computer, which you can send messages to, get responses from, and which you as the user and developer can treat as if it were, in some sense, logically singular, right? You don't have to reason about many things. You just have to reason about one. That's the sleight of hand that people want. They don't want a blockchain. They want a thing that behaves like a world computer. How do we get there? So if we look at the distributed system, we have a bunch of stuff going on, and we want it to behave like one computer. This seems to me like a problem for protocol design. We want users and developers to be able to act as if they're interacting with this simple and singular abstraction, and somehow have the protocol do the job of translating those interactions into all of the messages, and there's a lot of messages, as the 00 just talked about. Messages are very important, and there are a lot of them, and the user is definitely not going to specify which which undersea cables should be used to, like, this is an old example, but buy their CryptoKitty, right? They're not going to specify that. They're going to specify a much higher level thing, and we even want to make, at least if we take this world computer concept seriously, we want to make the higher level thing look like this on the left. What makes this a world computer as opposed to the Ethereum blockchain? I would argue two central things. One, there's logical centrality of a programming environment and a user interface. A world computer can be programmed and reasoned about as if it were one machine of some form. And it's not going to be, the same as your laptop, like it would have to represent, for example, different data consistency models. But it's only a world computer. Ethereum is the world computers. Ethereum is the world computer. It's singular. So it's only a world computer if it has this kind of logical centrality. But you want this world computer to actually abstract the capabilities of the underlying distributed system and give the programmer and users power over it. And this includes, much more than just running transactions on a blockchain. It includes how things should get routed around the network, what things should be optimized for, eventually consistent state that you need for something like IoT, etc. So just to make that point ironclad, things that aren't world computers, Motorola 6502, who knows what that is? It's a really, really old Motorola phone. Ethereum, layer 1, you don't get any power over the distributed system. The only thing you can do is run transactions. Ethereum layer 1 plus rollups, there's more stuff going on, and there are more options, certainly, for trust models, but there's no logical centrality. You can't program it as if it were one thing. Solana, et cetera, for the same reasons. So how do we get there from where we are today? I'm going to offer up two directions. One is the kind of more opinionated Anoma direction, and another is a direction involving a new version of the EVM. First, though, I have to give a small confession. As you may, probably have expected, Anoma did not set out to build, quote, the world computer. We set out to build general intents, alternative economic systems, stuff like this. Until last year, or maybe about 6 months ago, I took the phrase world computer to just be a marketing slogan, which, to be fair, was also what it was originally intended as and didn't pay any attention at all. But we've stumbled into this abstraction, or something that really looks like a world computer, backwards and at least metaphorically drunk, which I think makes, provides a bit of evidence that it's interesting. It's not something that, it may be more interesting than a marketing slogan. You don't find good abstractions, they find you. So how does Anoma offer a potential path for Ethereum to become a world computer? The path Anoma offers basically involves a gradual upgrade to a new state architecture. And the main thing from the perspective of making this distributed system act like a world computer that is different about Anoma's state architecture vis-a-vis Ethereum is that the units of state are really small. In Ethereum, the units of state are big. They're smart contracts, and smart contracts have a lot of methods, they have a lot of functions, they have a lot of state, and that's hard to distribute because it's all written as a big contract. Now, someone could try to, and this is related to the second path that I'll discuss later, someone could try to take a smart contract, which has 55 methods or whatever, inheriting a bunch of stuff, and separate out the individual units of state and somehow split the smart contract logic such that the smart contract logic is packaged with individual units of state and distribute the individual units of state in that way. But this is pretty tricky when the programming environment isn't designed for that. Also, Ethereum or the EVM only supports totally ordered transactions. You would need a different, some kind of async messaging or something. So you need a lot of changes. So Anoma has designed a state architecture that we think is more compatible with this world computer concept involving lots of units of really small state. But programming these units of really small state directly is a pain in the ass. It's actually maybe even harder than programming Ethereum smart contracts because at least they group things together for you. So instead of having developers do that, what we've been working on is a way to translate these kind of high-level descriptions of applications as logically central to little units of state that can be distributed all around the network, but to ensure in that translation, which involves both kind of compilation and checking, because sometimes you can't automatically synthesize everything, to ensure that that translation acts as if it were one thing, as in users can treat applications as if they're a single box running on a world computer. The state of an application is distributed, but an application behaves as if it were singular. That's the goal. So just to describe that pictorially, the idea is that an app on Anoma, similar to how I said, a world computer is not a physical thing. It doesn't live in a particular physical place. We just want the distributed system to behave as if, as if it were central. In Anoma, apps are as if it were central. They don't live on a particular chain. Rather, they have some interface and then some state, which is distributed across the distributed system. And the way you write apps in conjunction with the compiler translates messages. So when you do the thing that as a user looks like sending a message to an application, the protocol does the job of translating that to a bunch of messages that you send around the distributed system. And when you get messages back, same thing. So the goal here is to simplify the abstraction so users can act as if they're interacting with the thing on the left when the real thing is the thing on the right. That's probably abstract. So let's go through this concretely with a very simple application, which we call Kudos, but you might know better as just a fungible token. And we're going to simplify this down to the absolute bare essence needed to illustrate the concept here, which is a version of Kudos that has only two functions, or only two kinds of interaction. One, you can transfer some Kudos from somebody to somebody else in some amount, and providing, of course, a signature. And two, you can query the balance of your account. These are the only things that you can do. And we want a Kudo app that behaves, you can guess what the invariance will be. If I transfer to you, my balance should go down, your balance should go up. We want a Kudo app that behaves as if it were a single object, basically. Users send messages to it, other users send messages to it, the invariants are always preserved, and no one needs to worry too much about the distributed system in the background. But we have a distributed system in the background, and that distributed system has bunches of little Kudos. There's not, in fact, one Kudos object. There are many different little resources, and each of them, you can think of them as just Bitcoin-style UTXOs for the purposes of this example. There's 5 Kudos owned by Satoshi, 3 Kudos owned by Vitalik on yellow L2, or maybe Ethereum. There are 4 Kudos owned by Michael, 6 Kudos owned by Satoshi. On blue, where would you like your Kudos to be? We'll say that they're on a Bitcoin L2. So we actually have this distributed state, and we want to make it act as if it were this magic Kudos box. How do we decompose or compose those interactions to make the interfaces match up? Well, there are some more general procedures, which you can find described on some threads on our research forums and elsewhere, but I'm just going to list the specific decomposition in this case. When you transfer, we need to do a few things in the actual distributed system to make it look like, to a user, you're just transferring. One, we need to find some Kudos resources because they're all around the system. So we need to gather up the ones that we need to consume in order to create some new ones. And just to mention it, the resources in our model are immutable. So you can only consume and create them, similar to Zexy or various Zexy, if you know these state models. So the first thing we do when the user does something that looks like sending a message called transfer is we find some Kudos resources, try to find enough in order to execute the transfer that the user wants, and then we destroy them and we create them anew for the recipient. Now, as you can imagine, these resources are in different places. So this might actually require multiple transactions. And nothing here is magic. We can't magically make cross-chain transactions atomic, at least if they have different validator sets. But we can do something that respects this interface. In particular, because the user owns the Kudos, we can stage the transactions with rollbacks if there's some conflict on the other chain. As in, if we have let's take this example. Satoshi, in our example, would like to send 11 Kudos on red chain, which is not included here, to Michael, right? So what Satoshi does, or what the application does when Satoshi calls transfer, is 2 transactions. The first one takes the 5 Kudos on yellow chain and moves them to blue chain along with instructions to take the 6 Kudos on blue chain and move them to red chain, sending them to Michael. And if the 6 Kudos on blue chain are no longer there, then the 5 Kudos just go back to yellow chain. So from the perspective of Satoshi sending these Kudos, executing this transfer, the interaction is atomic in the way that Satoshi cares about, right? either 11 kudos get sent to Michael, or Satoshi gets back what he originally had, no change happens. So it behaves as if it were one object, even though the underlying system is distributed. And I think this pattern is fairly common. I mean, it's not true for everything, but often, users are executing, even when users need to move state across chains, they're doing so in a way that they control it, which means that you don't need to do multi-phase commit or super complicated things. You could just have rollback logic in between. But if you go, use an application nowadays, when you have, even if you just are in Satoshi's situation and you have different assets in different places, you have to do all of this, gradual transferring. I mean, for the most part, by hand. At least I don't know of a wallet that will aggregate all of your assets on heterogeneous trains and allow you to click one transfer button and send them to another party. But someone could abstract over specific chains. Gotcha. Yes, so let's talk then about what query does. Again, we want query just to find the balance of a user, and it does that in our implementation by finding all the Kudos resources. That's a distributed query, go to multiple chains, summing them up, and returning the result. There's no magic here. There could still be different domains, some of which are available, some of which are not. We're not assuming that the whole system is available. So balance cannot query unavailable locations. You can't atomically send more than you have in one place, but you can do this kind of aggregation with rollback that I've described. But we've succeeded, I argue, in providing a clear abstraction. This Kudos app behaves as if it were one thing, and the only thing the user has to reason about is, do I want to transfer? Who do I want to transfer to? And then query my balance. They don't need to care where the state is. Now, they probably want to express some preferences over, if I'm a receiver, maybe in my address, I specify where I want to receive the assets. So that's how I would express my security preference there. And maybe sometimes you have a more complex transfer function that allows the user to pass additional constraints. But users, most of the time, aren't making these decisions about security choices in every single interaction. So most of the time, the interface can be this simple. Maybe you have some configuration that sets some other defaults. So in Anoma, applications live in this virtual world computer. They expose this kind of logically unified interface. Developers and compilers working in conjunction make some decisions about the actual distributed messaging, but you can check that the distributed messaging, as it is implemented, preserves something that behaves like this logically unified interface. Now, Ethereum doesn't look like this. At least in the year, well, this is a year old. There's probably more stuff now. There's a lot of stuff, right? Not one, just many things. That's the essential difference. How could we upgrade it to behave like a world computer? The opinionated Anoma path involves gradually deploying sort of various components that allow Ethereum to gradually upgrade to this kind of state architecture. So components that we call protocol adapters, which are smart contracts that can be deployed to Ethereum main chain and L2s that provide basically an implementation of this state architecture and interop logic with EVM state, and Anoma nodes that can be run alongside Ethereum validators or layer 2 nodes. But maybe this isn't the path that you want to take. You could still be interested in this world computer abstraction and want to do something else. Maybe you want to try to support the EVM still in some way, et cetera. Many people are waiting to see if we will ever ship something that isn't a research paper. So two other paths that I want to describe here quickly today. One, rework the EVM. Two, do something else entirely. What would it mean to rework the EVM to be able to provide this kind of logically unified world computer abstraction? Let's call this EVM2 World Computer Edition. Well, one thing you'd need to do is you'd need to add ways for smart contracts to control how they are moved across chains, across domains. Because if you want to provide an application that behaves as if it were singular, you need to enforce some things. You can't have contracts moving all the time, but they need to move sometimes. Currently in Ethereum, they just don't move at all. Instead, they write other logic that's like send a message to my other contract on this other chain, and then the other contract on the other chain does something, but the contracts themselves don't move. You would need to add asynchronous message calls. These can be actually executed cross-chain. You would need to add, Ethereum has these these very, very, very simple read-only functions that no one actually uses as read-only transactions. Instead, they run them locally using the Web3 API. But now, mostly, they don't even do that. They use some other system like the graph. But if you want a thing that's logically unified, you need it to support reads in addition to writes. So you need to add all of these capabilities into the EVM2, and you need to compile them to the actual distributed system. There's probably much more. I haven't thought through this a lot, and I'm not an EVM expert, but it is a direction you could go. And you could go in this direction and end up with something that is closer to the concept of world computer that I've described here. Maybe something else you can do, you could build a new VM. I hear RISC-V is popular nowadays. Most of the state architecture problems are going to be the same, but you could build a new VM extending RISC-V with the RISC-V sort of compute instruction set and add these components. If OpenL2 does the work, then Gavi the tech, or buy them out. Buy Vitalik a really, 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 really beefy laptop and just accept that like all of our financial markets will trade on Vitalik's laptop, and maybe as a solution to the tragedy of the commons, this is better than what we are currently doing. So there are arguments for it, or something else altogether. So 3 takeaways. One is just, if people are serious about world computer, I think we need to take it more seriously than taking it as a marketing slogan, saying world computer, gesturing to the blockchain, and acting like we're done. That's not working, and the world has kind of noticed that it's bullshit. So you, or we, or they, or whatever you might identify or not identify as it relates to Ethereum, must take this problem seriously, and I have done my best to give you a glimpse of what that might look like. Thank you.